In this video, we're going to talk about the basics of dependency injection. We've already been seeing this some in the course, and let's take a little bit closer at it. So this is a quote from John, I hope I don't say their name, Munch. I hope I'm saying his name correctly there. So dependency injection for 5-year-olds. When you go and get things out of the refrigerator yourself, you can cause problems. You might leave the door open. You might get something mommy and daddy doesn't want you to have. You might even be looking for something we don't have or which is expired. What you should be doing is stating a need. I need something to drink with lunch. And then we will make sure that you have something when you sit down to eat. So this is really kind of the concept of dependency injection. You are saying in your classes that you need this object to work with. So you're basically declaring that you need it for your class to function properly, and you don't worry about how it is provided to you. So it's an important concept how that works. So dependency injection is where a needed dependency is injected by another object or another program. It can be at instantiation via constructor, or after the object is created via a setter, or in some cases, not optimal, but direct property access. The class being injected really has no responsibility in instantiating that object that is being injected. Some people say that you avoid declaring objects using the word new. I've seen newer developers believe that this is a rule that you need to work by. And I say this not 100% correct. There are going to be instances where you do create a new object. Just when you start getting into dependency injection, be pragmatic in your approach of what is and is not being managed in the Spring context. You don't need to manage every single object in the Spring context. So be pragmatic in the approach of using dependency injection. It is a powerful tool, but it can also be overused. Types of dependency injection. By class properties, that is the least preferred. These can be public or private properties. Using private properties, you can do this. I considered it evil. You can see there I have that in red. If you have a private property, Spring can actually use reflection to go ahead and set that at runtime. This, air quotes, works, but it is slow, and it also makes your testing difficult. It becomes a kind of a headache to test classes where you are performing dependency injection on private properties. By setters, this used to be an area that most people preferred, and going from old memories, I think Spring was a little temperamental using constructors in the early days, but that is much past. There's been a lot of debate in the community about this. By constructor is the most preferred now, because when you are instantiating the object, to create the object, you need to pass in that dependency via constructor, so the object cannot exist without that dependency being injected into it. So concrete classes versus interfaces. Dependency injection can be done with either. Generally, you want to avoid specific concrete classes. Dependency injection via interfaces is highly preferred. It allows that runtime to decide the actual implementation of the interface to inject. So this follows that integration segregation principle of the solid paradigm. And it also makes your code more testable. So if you are injecting an interface, if you need to mock that at test time, that becomes very trivial to do. So it's very easy to do that. So your life will be much easier if you're using interfaces for your dependencies. Inversion of control. This is a concept that some people struggle with. Inversion control, it's also known as IOC. This is a technique to allow dependencies to be injected by runtime. The dependencies are not predetermined. This really allows your framework to compose the application by controlling which implementation is injected. So a great example, we've already seen in the class that how we used a H2 in-memory data source. It would be trivial for me to reconfigure that application and use a MySQL data source. And the only difference there is that we'd be injecting in a MySQL data source over H2 in-memory data source, and the application would function either way, but one would be talking to an H2 database, the other would be talking to MySQL. So with inversion control, it's important to remember the control of the dependency is being inverted over to the managing framework, which in this case would be Spring Framework's inversion of control. This is another quote by Ralph Johnson and Brian Foote. One important characteristic of a framework is that the methods defined by the user to tailor the framework will often be called from within the framework itself, rather from the user's application code. The framework often plays the role of the main program in coordinating and sequencing the application activity. This inversion of control gives frameworks the power to serve as extensible skeletons. The methods supplied by the user tailor generic algorithms defined in the framework for a particular application. So what they are saying here in a nutshell is that the framework is going to provide a lot of work, and you are not going to work with the framework itself directly very much. However, you will be focusing your development efforts not on the framework, but on the application code. And the framework will then assemble your application for you. So very, very important concept here where we are working in conjunction with the framework to build our application, but we are not really calling the framework. It's very rare that you need to actually call a Spring framework method or class. The framework does a lot of the heavy lifting for us. Now, inversion control versus dependency injection, these are really easy to confuse, especially if you're new to this type of program. So dependency injection really refers to much of the composition of your classes. So you compose the classes you are writing with dependency injection in mind. You might even write code to inject a dependency for a unit test, and I'm going to demonstrate that coming up. So the act of injecting a dependency is technically dependency injection. Inversion control is the runtime environment of your code. So you are taking your application code, putting it into the Spring Framework runtime environment. The control of dependency injection is then inverted to the framework. So Spring is going to be in control of what dependencies are injected. For example, you could have an application that has an H2 in-memory database and a MySQL database and that data source. That you can set up a switch as to which one gets injected. So your application will run on both, but at runtime, you decide which database you want to be talking to. Now, some best practices with dependency injection. Always favor using constructor injection over setter, and especially properties. So when you set up a dependent component, the ideal is to use final properties for the injected components. Declare the property private and final, and then initialize it in the constructor. So that is the ideal. And whatever practical, code to an interface. And then finally, not everything needs to be performed with dependency injection. If it's something trivial, I recommend just being pragmatic about it, like a date formatter. You don't want to be doing that unless you need that date formatter universally available in your application. So small things like that really don't get a lot of benefit, but something like a data source definitely does get benefit from using dependency injection. Coming up in the course, we are going to explore these topics a lot deeper.